So for years, we've all heard about this key climate target, right? Keep global warming to 1.5 degrees Celsius. But what happens when we blow right past it? Well, the world is now entering a new and pretty dangerous era that scientists are calling climate overshoot. Let's get into what that actually means. And look, this isn't some far-off futuristic problem. The consequences are already here. They're all around us. We're talking about massive wildfires, soaring heat stroke deaths, and these extreme floods that have impacted a fifth of the world's population just in the last decade. I mean, just listen to this. That's a quote from Robert Watson, a guy who used to be the chairman of the UN's top climate science body. When he says climate policy has failed, it really sets the stage for a new reality. The old strategies, they're just not going to cut it anymore. So the big question is, how did we get here? Let's take a look at the broken promise that's pushed us over the edge. This is the key. This is the whole ballgame right here. We're not just talking about a single hot year. The period from 2023 to 2025 is the first sustained multi-year breach of that 1.5-degree line. That's not just a temporary spike. It signals a new, stable, and much warmer state for our planet. And if you look at this graph, you can see it plain as day. This isn't a prediction, it's a measurement. You can see that sharp upward swing, way above pre-industrial levels. That's basically the before picture, before we started burning fossil fuels like there was no tomorrow. We've now officially crossed the line we swore we'd never cross. Okay, so we keep throwing this word around, overshoot. What in the world does it actually mean? To put it bluntly, overshoot means we failed. It's that period when we go over the limit with the hope that we can somehow reel temperatures back down later. The two most important words in that whole definition are temporarily and potentially, because there are no guarantees. And that right there brings us to the core danger. Because even a temporary trip into the red zone might trigger changes that are anything but temporary. And it's a fair question, right? You might be thinking, what's the big deal? If we can bring the temperature back down, what's the harm? Well, the problem is, some of Earth's biggest systems, they don't just bend, they break. And this is the whole concept of tipping points. This map right here, this is basically the planet's playbook of potential disasters. These are what scientists call tipping points. They're like thresholds where just a little bit of extra warming can push a massive natural system into a whole new state, one that it can't come back from. And we are not talking about small things here. The systems at risk are monumental. We're talking about the collapse of the giant Greenland and West Antarctic ice sheets, the shutdown of a critical Atlantic Ocean current, the death of the Amazon rainforest, and saying goodbye to pretty much all of the world's coral reefs. To really let this sink in, let's just focus on Greenland for a second. If we cross that tipping point and that entire ice sheet melts, eventually global sea levels will rise by 23 feet. And that's not some wild guess from a computer model. That's just how much water is physically locked up in that ice. And get this isn't some far-off threat. Right now, Greenland is losing 30 million tons of ice every single hour. The process has already started, and scientists have warned that the point of no return could be triggered right around 1.5 degrees of warming, which is exactly where we are now. But here's the kicker. The danger doesn't just stop with one system failing. The real fear is that all these systems are connected. This is the scenario that keeps scientists up at night, the domino effect. It's the idea that the collapse of one system actually creates the perfect conditions to topple the next one and the next one after that, leading to this cascade of planetary changes. So here's how a cascade like that could actually play out. First, the Greenland ice sheet melts, pouring these unbelievable amounts of cold, fresh water into the North Atlantic. All that fresh water disrupts a massive ocean current we call AMOC, causing it to shut down. Then, that shutdown messes with weather patterns all over the globe, leading to the collapse of the Amazon rainforest. See? One thing triggers the next, which triggers the next. So if we're stuck in overshoot and staring down these tipping points, is there any way to go back? The choices we have now are, well, they're difficult, and they're really controversial. When you boil it all down, there are basically two big ideas on the table. The first one is negative emissions. That's literally sucking carbon dioxide that's already in the air back out. The second is geoengineering, which is a much more direct approach, something like creating a giant sunshade for the entire planet. Okay, let's talk about the biggest challenge with negative emissions, scale. Just look at this chart. Our best efforts right now, mostly planting trees, pull about 2 billion tons of CO2 out of the air each year. That sounds like a lot, right? But to cool the planet by just 1/10 of a degree, scientists estimate we need to remove 200 billion tons. The gap between where we are and where we need to be is just staggering. So, what about the other option, geoengineering? Well, Robert Watson had this incredible analogy. He said it's like turning on the air conditioning in response to a house fire. Sure, it might make the room feel cooler for a minute, but it does absolutely nothing to put out the fire, the CO2 that's causing the problem in the first place. And despite all these terrifying scenarios, you'd think the political response would be lightning fast, right? Well, it wasn't until 2025 that UN negotiators even officially acknowledged that we need to start planning for an overshoot world. There's a huge, dangerous gap between what science is telling us and what policymakers are doing. Which really leaves us with this final sobering question. We know now that the planet has physical tipping points, points of no return. But maybe the most important tipping point of all is the human one, our collective will to act, before there's really no way back.